Yes, welcome back to the session. In this video, I'm going to discuss about electric potential due to a point charge. Okay, so first of all, I will draw the diagram. Let's say, for example, I have a charge Q which is located exactly at point O, and there is a point charge, let's say, for example, plus 1 coulomb, which is located very near to infinity. Let us assume the point charge location is at point A. Okay, so I'm connecting a line. So the distance of separation between Q and point charge is, I'm taking X. So X is the distance of separation between the charge Q and 1 coulomb. Okay, so according to Coulomb's law, electric force between the two charges is F is equal to 1 by 4 pi epsilon naught into Q1 Q2 by R square, right? So here Q1 value is Q and Q2 value is 1 coulomb. So I'm going to implement this condition for this formula. Okay, let's see. So F is equal to 1 by 4 pi epsilon naught into Q1 value is Q into 1 coulomb. That is nothing but Q into 1 means Q by the distance of separation is X. So X square. So let us assume this is equation number 1. So whenever a source charge is present here, due to which electric field is acting radially outward direction, right? Correct or not? Now my aim is I'm going to bring this test charge from point A to point B towards the source charge, that means this side. So that definitely I have to apply some external force, right? Correct or not? So this force is against to electric field. So due to this external force, let's say for example, object displaces dx distance. So the product of force and displacement is called work done, right? So I'm writing here. So work done to move, a 1 coulomb of charge from A to B is dw is equal to f dx cos 180 degree. Here cos 180 value is minus 1, right? So therefore dw is equal to minus f dx. So let us assume this is equation number 2. Okay, so already f formula we know. So I'm going to substitute in equation 2. So substitute equation 1 in 2. Therefore dw is equal to minus 1 by 4 pi epsilon naught into q by x square into dx. Okay, now the point charge reaches to point B, right? Let us assume the distance of separation from O to point B is R. So initial limit is infinity, the final limit is R. Now what I'm going to do here, I'm going to integrate this equation. So the integral limits is from infinity to R. So we know that integral dw is nothing but w. So here the constant terms I'm taking outside. So minus 1 by 4 pi epsilon naught into q. So that q directly I'm writing here. What is the rest of the equation? Integral infinity to r 1 by x square into dx. Okay, so this 1 by x square we can write like this. So minus q by 4 pi epsilon naught into integral infinity to r x power minus 2 dx. So this equation, it looks like integral x power n dx, right? So which is equal to x power n plus 1 by n plus 1. So I'm going to use this formula to modify this equation. Let's see. So minus q by 4 pi epsilon naught into x power minus 2 plus 1 by minus 2 plus 1, which is varying from infinity to r. So minus 2 plus 1 means minus 1. So therefore minus q by 4 pi epsilon naught into x power minus 1 by minus 1. So look at here. So this minus and minus 1, I mean minus minus plus. So therefore, the rest of the equation we can write it as q by 4 pi epsilon naught into this x power minus 1, we can write it as 1 by x. Okay, so which is varying from infinity to r. So first I'm going to substitute the maximum position, I mean final position and then initial position. Let's see. So q by 4 pi epsilon naught into 1 by r minus 1 by infinity. So where 1 by infinity is equal to 0, so therefore the rest of the equation work done is equal to q by 4 pi epsilon naught into r. Basically this work done is nothing but in the form of electric potential. So V is equal to 1 by 4 pi epsilon naught into q by r. So this is the final expression for electric potential due to point charge. Basically this derivation is important for 5 marks, especially for PU board. Okay, I hope you understand. Thank you so much.